Good morning, problem solvers, or whatever time it is when you're watching this video. This is the ice sheet for functions. Hopefully you've watched the PowerPoint already that's been narrated, and now we're going to work on the ice sheet. Normally you would have time in class to work on this in groups, so I'd encourage you when you watch this to read the problem, pause the video, think about it some, and then listen to me carefully and maybe stop me before the answer goes all the way through. And then try to think about it some more, see if you can kind of use a hint and get a little bit farther, and try to figure it out somewhat for yourself. Certainly we can talk about it though in the class Discord or vocally during office hours. Okay, so let's go through the first one here. I have a set A, which is just the month and the year, January through December. Given an element of that set, so given x and a, the output of this function is the number of days in x. So f define a function from a to the natural numbers to that codomain. Why or why not? Well, let's just try the function. So f of January, that'd be 31. F of November would be 30. And each month I know what to put out, right? I'm not going to get two different days unless you account for leap year. So there's one little niggle. Is this 28 or 29? So if we actually care about leap year, then this is not a function because it's not well defined. I don't know what the output of February is. If you forget about leap year, then yes, it would make a function. Okay, let's go to the second one. By the way, there's lots of problems, which means these aren't quite as tough as some of the other sheets. You can tell when a sheet only has 3 or 4 problems, it's going to be some toughies. Okay, so it says find, if possible, the inverse of the function f from z to z, so from the integers. Make sure to check that the inverse satisfies the definition of the inverse of f. So we'll call g f inverse. So I want the function where f of g of x equals x. And I'm going to show you the method that you probably learned in pre-calculus, which is when you have f of x equals x plus 2, I'm going to write y instead. And then the step here is to flip x and y, and then solve for x. Excuse me, solve for y. Solve for y, back to how you normally have. So that would be x minus 2 is y, and that would be g of x, or f inverse of x. So let's try that. If you take f of g of x, let's hope that we get x. Let's go back up here. Well, g of x is x minus 2 now. And f says take x minus 2 and add 2. You get x. If you do that the other way, you should also get x. I'll have you guys do that part, but that does work. By the way, a comment about this. X minus 2 still maps the integers to the integers. If you had done x cubed, so if f of x was x cubed, that can go from the natural numbers to the natural numbers. You get new ones. But f inverse would be cube root of x. That's not from the naturals to the naturals. That would have a different target space because what is cube root of 3, right? So you have to think about your domain a little bit. But for the function we have here, it really does go from integers to integers correctly. And now we have a similar one here. We've got square root of x. And we're going to say its domain we're calling big X. That is the set of positive or non-negative real numbers. So 0 to infinity includes 0. We've got a separate function from r to r through x minus 1. I wanted to find the composites and more about where they're at. If so, find formulas for them. So g circle f is g of f of x. I'm just going in order here. F of x is root x. So g of square root x, plug that into g, and this is supposed to be defined on f's domain, right? So this supposed to go, g circle f is supposed to go from x to r, and anywhere that you have a non-negative real number in the domain, this is okay. So that is defined in that way. That makes sense. If you go the other way, I've circled g, it's f of g of x. I want to go from, start with g of x, which is 3x minus 1, and then I want to square root that. Okay, so let's just think about this expression here. When is this positive? Well, this would have to be greater than or equal to 0. So x would have to be greater than or equal to 1/3. Okay, so this function makes sense only when x is 1/3 or bigger. F circle g is supposed to go from g's domain, which is R, to f's output, which is R. Okay, so there's two ways to think about this. Using strictly the definitions for this class that we have, f circle g is not defined because you can't do f of g of 1/4, for example, because you would get a negative square root. The way you usually do this in pre-calculus or calculus class is that you just say f circle g is defined, but it's on has a new different domain than either f or g. So that's really tomato, tomato. Strictly following the rules in this class, we would say that f circle g is not defined. Okay. Let's sketch the graphs of the following functions, considered as functions from the reals to the reals, which are injective, which are surjective, which are bijective. You can just bust out your graphing calculator for this, but in this class we're really trying to get some general skills, right? That's why your group midterm you didn't have a graphing calculator or anything like that. These, general for your calculus classes or any of your other math classes, these are good graphs to just have memorized. So I'm going to sketch them from memory here, and I encourage you to also memorize these graphs if you haven't yet. Okay, so x squared looks like this. I'm going to use I for injective, S for surjective, and B for bijective, and I'll just put a checker in x. It's not injective because it doesn't pass the horizontal line test, right? You have two functions, two x values going to the same y value. It's not surjective because you didn't hit the negative y values, and so you have to be both of those to be bijective, so not true. X cubed passes the horizontal line test. You can see that there. It's surjective because it hits every y value, and so it's bijective because it's both of those, which means it has a nice inverse cube root of x. E to the x has this guy here, grows, but on the left it heads to 0, and it is injective, passes the horizontal line test, although I can't draw it very well. It's not surjective because it doesn't hit everything down there. So we would not say bijective, so we would not say invertible from R to R. But then what is the point of ln of x? Well, ln of x is the inverse if you think of E going from R to x being 0 to infinity open. So that should be an open bracket there. Let me fix that. So if you think about it that way, if you think about its range as its codomain, then it's invertible there, which is why logarithm only has a domain of 0 to infinity open. But the question asks about reals to reals, so this is what we would say. All right, let's keep going with sine of x and arctan x. So sine of x looks like this, and keeps going, but we'll stop there. These should all be the same size, but I can't draw. Definitely not injective. Really fails the horizontal line test. Doesn't hit very many y values at all. Definitely not invertible. That's why to create the arc sine function, we chop it down to just a tiny little sliver, right? Because sine is very much not invertible. Arctan x should be invertible since it's the inverse of tan, right? Looks like this. It is injective. It is not surjective on R, but you can invert it on its, if you think about the codomain as its range. And its inverse, so not bijective here, but its inverse would be only one period of tangent, right? The one around the middle. But it's not surjective on all of R. Okay, so now we want to talk about the idea of taking the image of a set and then the pullback of a set. So I've got x squared, and I want to talk about the image of these sets. Okay. So the way I'm going to take f of 0, 2 is I'm going to square all these numbers. So if you think about x squared's graph, I'm really asking about, here's the graph, here's 0, here's 2. I'm asking about what are the y values of this strip. Well, they're from 0 to 4, closed. So this is 4 up here. If I take minus 2 to 2, and I go both ways, but I ask what are the y values that I get, I don't get any extra y values because x squared is even, you get the same stuff. So that's 0 to 4 closed still. Okay, so next we want to talk about negative 3 to 2, so I'm going to go a little bit farther. So there's minus 2, I'm going to go a little bit more. Well, negative 3 would go to positive 9. So this, then the y values start at 0, but they go all the way up to 9. And if I go the other way, I don't use that negative side, but I go to 3 on the right instead over here. That would still be from 0 to 9. Those are the y values put out by those x values. Then some happen more than others. 0 hits once, everything else hits twice, or maybe once, depending on the set. But I'm just asking which y values did I hit. Right? I'm going to go up to 9 now. And then lastly, I want to take all negative real numbers. So that would be minus infinity to 0 open, don't include 0. If I took all the stuff over here, I would get the positive real numbers, not including 0, strictly positive. All the negatives become positives. Alright, so that's 5. Now we want to talk about 6. And this is not an inverse because x squared is not an invertible function. I want to talk about pullbacks. So I want to know the numbers that went to these y values. So let's draw x squared again. And let's talk about 0 to 2 on the y-axis. And I want to know what are the x values that mapped to those y values. So the things that went to 0 to 2, so f inverse of this, would be negative root 2 to root 2. It's a bit more, right? It's both sides, close, all the way to minus root 2 to root 2. Now what about minus 2 to 2? Well, now I'm also asking what went down here to the negatives. Nothing did, so I'm not going to add anything here. These are the numbers that go to any of those y values, right? Nothing else got added, so I don't make this pullback any bigger. Now I want to pull back 4 to 16, closed. Okay, so that's way up here for the y values. But you can see there's going to be stuff on both sides, and they're going to be separate. That certainly is from 2 to 4, closed, but also minus 4 to minus 2. And I'm going to union those two sets. So I get two different chunks, right? There's the stuff over here and the stuff over here that go to those y values. Now, what if I pull back all of the non-negative real numbers? So I pull back 0 to infinity. Well, that's going to be, non-negative would include 0. Well, that's the range, right? That's the range of not the codomain, but that's the range of x squared. So I just get the whole domain, which is all of R, right? What about the negative real numbers? If I pull back the negative real numbers, nothing went there, so I would get the empty set. There's nothing that went to those spots, so the prerange of that is nothing. Alright, so that is the ICE sheet for the functions lesson, lesson 13.